Well, thank you very much for this opportunity. We have gathered here for Passenger Vehicle Forum, which has a tagline, Disruption is an Opportunity. Let's understand the meaning of disruption by asking it from Google itself, as we are talking about connectivity. So, hey Google, can you please tell me the meaning of disruptive?
In business, a disruptive innovation is an innovation that creates a new market and value network and eventually disrupts an existing market and value network, displacing established market-leading firms, products, and alliances.
Is your Google as fast as this? I don't think so. But technology in this world is moving much, much faster than this. Here, we are talking about the industry as a whole of automotive. Let's get back to the flashback of this industry.
Everywhere today, roads are being improved and modernized. New roads built, old roads rebuilt, concrete roads, macadam roads, and good gravel roads. But we still have plenty of just plain roads. And even the smoothest looking roads are often deceiving. Such roads show on examination long waves which can't be seen from the driver's seat. When motorists drive slowly over such roads in yesterday's cars, they get a smooth, easy ride. But as soon as they speed up, the camera shows you that cars are bounced around with a great deal of discomfort to the passenger. That's because there are two sides to this problem of riding ease. First, the size of the waves in the road, and second, how close they come together. When you drive 60 miles an hour, you're going a mile a minute. And if there are 80 long waves in a mile, you're jolted around 80 times a minute. Too fast for comfort. But with modern spring suspensions, motorists travel over such roads in comfort at any speed. For many years, engineers worked on this problem of easy riding from every angle. Springs were studied. They were made short, then long, narrow, then wide, with blunt ends and tapered ends, and they were made of various kinds of steel.
Thankfully, we don't have to do all this research and R&D today, as we are moving much ahead of this technology. But today, we are talking about carbon fibers. Why is it disruption? Because it is world's lightest and strongest material available for commercial use compared to steel. Presenting to you Future Composites. It's an organization which is a subsidiary of Expo Machine Tools Private Limited in technical collaboration with Nexcoms Limited. Let's get some inspiration from BMW i3. Why exclusively BMW i3? This is the only model which is commercially available, and it has internal structure and body made with carbon fiber reinforced composite polymers. We should learn from this technology. We should learn from BMW how this material, CFRP and GFRP, can be used commercially for each and every vehicle, not only for electric vehicles, but for all passenger vehicles. So these are the today's suspension coil springs that are available in industry and which are being used regularly with all the OEMs. These are made with steel. We have CFRP and GFRP springs. So we have the samples available here so that you can have a look and feel of this product. The major benefit of using CFRP and GFRP springs is that it has a weight of only 1 kg average compared to the normal steel spring coil that we use, that is approximately 5 to 7 kgs each. So if we are using CFRP, that is carbon fiber reinforced polymer composite, it is having a weight of 0.88 kgs each spring compared to 7 kgs or 5 kgs of the steel spring. And if you are using GFRP, glass fiber reinforced polymer composite, for the same spring application, that is 1.1 kgs each. So we are getting a weight reduction of more than 74% in each spring. So look at the benefit that we are going to get in the entire car. Each car has 4 springs. So the weight reduction, and then fuel efficiency, and then we have the better performance of the vehicle. Tested and tried in Korea itself, and now already implemented with one of the esteemed OEMs in India, approved also. These springs are being tested with the number of cycles compared to the steel springs, and yes, it has performed 24% better to the spring which are being used with steel. So they have a full bump load of, on the load of 4920 Newton at full bump, they have a shear stress of 197.3 Newton per millimeter square. So I will not go into the technical details right now. This is the data which is available with us, and I can share more when we are offline. So these are the different type of tests that are being done on the springs. One is spring constant, creep test, fatigue cycle test, fatigue creep test, simulator, and weighing measurement. Yes, we do not call it as old technology now, but these leaf springs are also available in CFRP and GFRP. Another application, that is the knuckle application. So this application is supporting the car body at the front or rear wheel axis and connects to multiple parts. This part also has a weight reduction of 40%, and the performance index says the static stiffness, the fatigue resistance, and impact test. Moving on to this application, there is a comparison of CFRP versus steel. On the stiffness test, we can see that the performance is almost equal, in fact better. These are some of the photographs of the same application. This is also known as carrier and knuckle. So these are again the results that we have achieved. I don't want to go through each and every test and the result that we have got, because I know we have passed all the tests compared to the steel application. So these are again the tests for that. That is camber stiffness test, static strength test, accelerated durability test, fatigue test. These are the tests which are mentioned here, but there are much more tests which are already done, and this product has passed those tests. This is another lateral arm and lower arm. We have both the samples available here also. These are the application to assess the wheel rotation movement by the steering systems. Again, I don't need to repeat the same advantage of weight reduction and better strength compared to steel application. These are again a few photographs of the application. CFRP automotive wheel hub. We all know that this is the application which is used right next to the wheel, which absorbs and distributes the shock force of rotating and braking motion from the load as a part to connect between the brake and the rim. And yes, in next step, we are also going to launch the entire rim of carbon fiber, reinforced polymer. These are again number of tests which were performed on these products. Sidebars. We all know approximately 10 years from now, when Opel used to market this particular strategy, this particular feature as a strategy of marketing. They used to say that all the cars that we make are most solid, and they have the sidebars made up of entire solid steel bar, which will protect you from accident in any case, in any situation. They are being installed in the front of the vehicle, in the back of the vehicle, even in the right and left of the doors of the vehicles. So this is the same application that is being made in CFRP and GFRP, giving you lightweight and giving you better strength compared to that. Okay, so when we talk about the impact testing, when the accident takes place, the same performance is given by these lightweight materials. Stabilizer again is used in balancing the left and the right wheel of movement of the outside wheel. So these are the registration certificates and Korean patents that we have already achieved, and here are some more of the patents. Components and more. As I informed, this is the wheel rim, which is already made in carbon fiber. We are yet to launch it in India, but there are various applications for aerodynamics also, for military and defense also. Carbon fiber is used in many other applications as well, being the most two common features, lightweight and being stronger than the steel. Yes, our company is into two verticals. One is civil engineering and second is automotive. So I've already given brief about